All right, so we are evaluating definite limits by using U sub. Okay? We are evaluating definite limits by using U sub. So we have a theorem here. If G prime is continuous for all values on the closed interval from A to B, and F is a continuous function on that interval containing the values of G of X for all values between A and B, then the following holds true. So first of all, this is our U sub, except now we have an upper and a lower bound. And really what this is saying is, in plain English, is currently when you are integrating in terms of X, you are given your bounds in terms of X. But in order to integrate and evaluate with respect to U sub, you have to change your bounds. Okay, and that's exactly what we're going to do. So here we're given our values of A and B. Okay? All right, and you have your composite function of G of X right here. Okay, so what we're going to say is that U is equal to G of X. So then du is equal to G prime of X dx, which is what we've got right here. Okay, so this is just kind of a review of what we've done before. So now we're going to make our substitution. So this is our U. So now this is what we've got. Here's our du. This is now our f of u. I don't like this notation at all. Here's du. But now the scenario is just a little bit different. This g of a and g of b means that we are now changing our bounds. Okay, and what we're going to do is create a table over here. This will be our original x value, meaning these bounds right here, and I'm going to put them in this table in the exact order that they are so that when I transfer those values back to my integral, they're in the exact same spot, meaning this b is on the top, this a is on the bottom. Okay, and then we made our u sub over here equal to g of x. So what we're going to do is we would plug in our values. So this here would be g of b, meaning whatever the value is once I plug in b, and g of a. So this would be my upper bound, and this would be my lower bound. So this is what we've got here, g of b. These are going to be numbers. Okay? So when we're using u sub for a definite integral, you must change your upper and lower limits to be consistent with the variable integration of u. So you can't leave the bounds the same. All right? Now, there's a couple different ways that you can do this. It is easiest to just leave your integral, excuse me, in terms of u and set your new boundaries, but you can also resubstitute. So let me just kind of go through one example and we'll see how this works. So we want to evaluate these integrals. This is clearly a u sub, okay, because we have a higher power in the denominator. It is a quotient, and I'm not multiplying this out 3 times. It's just going to get too messy. All right, so what we've got is u is equal to x squared plus 2. So if I make this equal to x squared plus 2, what do I need to get rid of? And I'm going to be consistent when we did u sub last time and highlight in green. What needs to go away? The x and one more small thing. Yeah, my x dx. So when I take the derivative here, du, this is 2x dx. How can I make this become the x dx? Okay, so I've got 1/2 du is equal to x dx. So this is what I wanted to get rid of. Everybody good so far? Okay, so what we have is the integral, don't write your bounds yet, of 1 over u cubed du. Bless you. Now the issue here is that these bounds are set for x when my integral was in terms of x. Now my integral is in terms of u. So what you're going to do is create a table, just like I did up there as my example, okay, and I'm going to put my x values here in the exact same order, -1, -2, And then I'm going to convert them to my u, which here we stated that u was equal to x squared plus 2. Okay, you're not going to have to write this each time, but I'm just showing you where I'm going to get these values from. So what this means is I need to take this x value and substitute it into my u sub. So negative 1 squared is 1, plus 2 is 3. Negative 2 squared is 4, plus 2 is 6. So now I'm going to transfer these two values up here. These are my new bounds with respect to u. So I'm going to put them in the exact order that they fall. So this is 3 and 6, and I have to put this 1/2 on the outside from my substitution over here. Okay, so now this is all in terms of u, including the bounds. Okay, what's the problem with the bounds? Okay, right. I need to flip them over. So how do we do that before we integrate? Yes, so this is negative 1/2 integral 3 to 6. And can I write this as u to the negative third du, because it's going to help me integrate anyway? Everybody okay so far? Yeah? Okay, let's integrate. So we're going to add 1, right? So we've got negative 1/2 times, when I add 1, this is what? Negative 2? So then what gets multiplied in front? Negative 1/2 u to the negative second to be evaluated from 3 to 6. Now listen very carefully. Sorry. You do not have to turn around and resubstitute x squared plus 2 back in. I can leave this all in terms of u. I reset my bounds. Does everyone understand what I'm saying? Previously, in the indefinite integrals, when we had our u sub, once we integrated, we would simplify and turn around and plug our x or our u sub back in. Does everybody remember what I'm talking about? But because I reset these bounds, I can leave this as u. It's going to make your life a lot easier. You don't have to plug anything else in. So now this actually becomes 1/4 times 1 over u squared to be evaluated from 3 to 6. So now what this is saying is, I'm going to leave this 1/4 out here because it's a coefficient. It's f of b, which is 1 over 6 squared, minus f of a. Okay, now the reason why we can do this is we accommodated for the x squared plus 2, okay, when we made our u sub and we created this table over here. So now we have 1/4 times, this is 1 over 36 minus 1 over 9. So what is that, 4 over 36, so negative 3, yep, negative 3 over 36. I know that can simplify. So what is that? Negative 1/12 times 1/4. So it's negative 1 over 48. That's my final answer, simplified. Okay. Before we continue, does anyone have any questions about what we just did? Yep.
Would you expect us to simplify that far on a free response?
Yes.
Okay.
Mm-hmm. But let's say you didn't. Let's say you stopped here. It's totally fine. Now on a multiple choice, you probably see this. But for your response, I mean, lots of different answers. You need to go, actually, you could probably stop here. I mean, that's the beauty of calculus, right? Okay. You should practice, well, you need to evaluate, so you can't stop here. So, okay, any other questions on the first one? Because it's going to take a couple examples, I think, for everybody to just feel more comfortable. You guys okay? All right, let's take a look. Let's take a look at B. What's my u sub?
E to the x.
Plus 4. Because I need to get rid of that. Because if I take the derivative of that, what's the derivative of e to the x plus 4? E to the x dx. Does everybody see it? All right, so we've got u is equal to e to the x plus 4. So that means I want to get rid of e to the x dx, right? Okay, so we've got du is equal to e to the x dx. Perfect. Okay. So now I will also need to create my table to reset my bounds. So this is x, natural log of 3, opposite of the natural log of 3, and this is going to be u. So what we have is the integral of 1 over u. du, right? So now I need my bounds. So we're going to plug this into this. True? Yes, no, maybe? Okay. So I'm going to write this out actually so that you can see it. So u is equal to e to the natural log of 3 plus 4. Okay, we did a problem similar to this the other day. Yeah, the answer is 7. Nice. Okay, now this is going to take a little bit more thought. U is equal to e to the natural log of, opposite of the natural log of 3 plus 4. Okay, this actually, something needs to happen to that. Say it one more time.
You can move the term to the denominator.
I can move the term to the denominator. Is that going to make it... you could. Okay, so if I move this to the denominator, it becomes 1 over e to the natural log of 3. So really that just becomes 1 over 3. Yes, and then I need a common denominator. So that totally works. Yes. So this is 1 over e to the natural log of 3 plus 4, which you then just told me is 1 over 3 plus 12 over 3, which is 13/3. Which you did just say, didn't you?
Yeah, Aaron said it.
Okay. Okay. Okay, so here's my question. Remember, I took these from the direct location, so that means the 7 goes here and the 13/3 goes here. Are they in the proper order?
Yes.
Yeah. Okay, you don't have to flip anything. What is the integral of 1 over u du? Yeah. So we've got the natural log of the absolute value of u to be evaluated from 13/3 to 7. Okay. So what we've got is f of b, which is going to be the natural log of the absolute value of 7, which is 7, minus the natural log of 13/3. Okay, technically, this is, bless you, correct if it's a non-calculator question. However, if I asked you to write this in its simplest form, does anyone know what you could do next? You got to think back to your Algebra 2 skills.
ln 7 minus 13. So then it's just like
ln 7 minus 13 becomes division. You cannot just subtract, like put these together and subtract. Remember, when you are combining logs, whether it's log base e or log base any other base, this now becomes division, right? So it's this divided by this, which is really this times the reciprocal of this. So it would be the natural log of 21/3. This is in its simplest form. Oh, thank you. 21/13. Okay, questions? No? Okay. I'm going to do D with you guys, and then you're going to go back and do C. So I'm going to give you a couple minutes to do C. Let's take a look at D. Okay, because we've got another natural log in here, and it's a hot mess. Yikes. All right, what's my U sub?
we're trying to get it to be signed, so you want it to be 1 minus x squared. So it's
I need to rewrite this first, then, is what you're saying? Okay. So Lauren said, this looks like it could be an inverse sine. So before we do anything, we need to rewrite this. So we've got the integral from the natural log of 2 to the natural log of 2 over the square root of 3. This is e to the negative x over the square root of 1 minus e to the negative x squared. Is that right? Like this? Okay, so now it's a little bit clearer what my u sub is. Remember, when we saw that it was either inverse sine or inverse tangent, it's going to be the one down in the bottom. So I'm going to go over here. U is equal to e to the negative x. And the substitution that I'm making is this one, because there's 2 of those here. So I just want you guys to see which one I'm substituting. So then you have, du is equal to what? Negative e to the negative x dx. So what do I have to do?
take that negative 1.
Yep. Negative du is equal to e to the negative x dx. So over here we have the integral of, I got to put my negative out here, 1 over the square root of 1 minus u squared du, right? And then I need to create my table. So this is x. So you've got natural log 2 over the square root of 3, natural log of 2. Okay, and this is going to be u. Okay, so let's plug these in, and we're plugging in right here to this one over here. So you've got e to the natural log, negative natural log of 2 over the square root of 3. That's my substitution. Square root of 3 over 2. Because it becomes 1 over this based on how we did that previous problem. So it's a square root of 3 over 2. Okay, so based on this pattern, what do you think this is going to be? Yeah, it's 1/2. Okay, can I ask you a quick question? Take a look here. You guys know that the integral of this is going to be what? Inverse sine. So you're asking yourself, in what angle do I take the sine of to get these values, and where are these values from? Yeah, the unit circle. Okay, so if this was like what if you got something different by accident? If it's not from the unit circle and you're evaluating without a calculator, something's going to tell you it's not right. Do you see what I'm saying? Did I make a mistake? I know you guys are looking funny over there. Okay, so this is the square root of 3 over 2. What did I do? Are these in the right order? Yes. Yes. Okay, they are in the right order. Okay, so this is going to be, you told me, the inverse sine. So what we have is the opposite of the inverse sine of u to be evaluated from 1/2 to the square root of 3 over 2. Okay. So now I'm just going to write it out so you can see it. I'm going to leave the negative on the outside. So it's inverse sine of the square root of 3 over 2 minus the inverse sine of 1/2. So what angle do I take the sine of to get the square root of 3 over 2? Say again? What is it in degrees? 60. So what is it in radians? Pi over 3. So then what's the inverse sine of 1/2? Pi over 6. Okay, this is 2 pi over 6 minus pi over 6 is pi over 6. The opposite of that is negative pi over 6. Okay. It could be. You have to know the unit circle. Really, it's more a test of if you can do the U sub too. All right, guys, you guys are going to do C. So I'm going to give you like, I don't know, 3 or 4 minutes, and then we're going to go through the answer.
When you do inverses, do you take the values from the first part?
Okay, so if we take a look here, I asked, what's the U sub? Someone told me it was 3x. Okay, so remember, this is a coefficient, so this comes to the outside. So then we just wanted to get rid of dx. So here when you take the derivative, this becomes du is equal to 3dx, so we had to get rid of that. So then we were left with 2/3 cosine of u du. We had to redefine our bounds in terms of u, integrate, and simplify.